We have figure BEST, and it's dilated about the origin with a scale factor of 2. We are asked to determine the slope of B prime E prime. I've graphed figure BEST in kind of blue, and then I dilated that about the origin by a scale factor of 2 to create B prime, E prime, S prime, T prime, which is in pink. We're focusing in on the length of segment B prime, E prime. We want to look at how that connects or relates to the slope of segment BE, which is the corresponding pre-image. What we notice is that B is the end point of segment BE or B prime E prime, and it was located at the origin. We dilated about the origin, so the segment is passing through the center of dilation. So the segment will be on that same line. It will just be longer, like extended, as in this case, or shortened. It will shrink, but it will stay on that same line. They're going to be collinear. So since B is the center of dilation, and segments BE and B prime E prime pass through B, the center, we know that they will be collinear. They are the same line. Or we could call them coincidental. Okay? So if they are the same line, they will have the same slope. So even without looking at the graph, we could have known that information, and we could have found the slope of BE, and it would have been the same as the slope of B prime E prime. So I can do the slope graphically as rise over run, or I could have done it algebraically as y2 minus y1 over x2 minus x1. So in this case, for B prime E prime, that would have been 8 minus 0 over 6 minus 0, which is 8 over 6, which is 4 over 3. Or we could have done rise and run. So you can see that our rise is 4 and our run is 3. Or we could do our rise is 8 when our run was 6. So we have a couple of different triangles. We could look at the rise and run for BE or B prime E prime, and we get the same exact slope, which is going to be 4 over 3. So the slope of segment B prime E prime is 4/3.